Force diagrams can be tricky when you're starting out. Here's an approach. Suppose you have a ladder leaning against a wall. First of all, the easiest force you can think about is gravity. So let's imagine that gravity acts on it. Where will gravity act on the ladder? It should act in the center of it, the center of mass. So we've got a force mg pulling straight down on it. Now before we go any further, I want you to take a moment and imagine what would happen to that ladder if that was the only force. Ladder would fall straight down. But that doesn't happen. So why exactly does that not happen? What stops it from falling straight down? The floor. What kind of force does the floor exert? Well, it might exert friction, but it definitely exerts normal force. Friction is not going to stop it going down, so there has to be normal force. And this is where it touches the ground, so this is where the normal force acts. Okay, so far so good. Before we add any more forces, again, what would happen to this ladder if those were the only two forces? Well, this is pushing up, this is pulling down, but it's also twisting, so it would fall over. It would rotate. So why doesn't it fall over? Because there's a wall there. What kind of force is the wall exerting? It could be normal or friction. But this thing is currently trying to rotate that way. The wall may or may not have friction, but have to have a normal force. So we'll call that normal force 2. Again, stop and consider, if those three forces are the only forces acting, what will happen to the ladder? It's got an upward force and a downward force, so it's not necessarily going to go up and down, but it's got a force to the right and no corresponding force to the left, which means this ladder is going to move to the right. Why doesn't it do that? The foot doesn't slide because we have static friction there. We know it's static because the ladder isn't moving, so force of static friction that way. And it's possible that there's some friction this way, but they often exclude it. They would say a smooth wall in that case.